Wow, 20 minutes is a short time, I just learned. Can really speed up. It's a real honor to be here and be a presenter at the first Congress. Again, very fortunate to be doing this. Is Wes Baker still in the room? Wes, thank you for a great prelude to my presentation today. So, why Interact sprinklers? With the advent of ESFR sprinklers, I have them just like this at home. There we go. It changed. It just works. No need. Yeah, there goes part of my 20 minutes down the drain. There we go. Just needed a professional up here to take care of that. With the advent of ESFR sprinklers back in the mid-1980s, the industry started spending the next 30 years basically trying to figure out a way to get rid of Interact sprinklers. But looks like they're coming back, and as Wes's presentation showed, there are many reasons why. Why are we going to want Interact sprinklers again? Higher buildings. We can put new buildings that are higher than 14.6 meters in height by using Interacts. The storage commodities have changed in an existing building. Maybe there were metal storage parts in there before and now we have plastics. Or if the water supply has deteriorated and we can't provide enough water for the ceiling sprinklers only. And higher buildings. This is the way the industry is going. Higher buildings using automated storage and retrieval systems. And we're talking buildings that could be 36 meters or higher. We have more exposed plastic storage. Vicky's going to be talking about storage buildings with roof slopes exceeding 2 and 12. With Interacts, that could be a way to get around that. And also storage buildings that are popular in Europe that have soft tube roofs. And what we discovered doing all this was that the main thing that we wanted to do was lower the water demand. If we use a horizontal barrier, not a fictitious ceiling, but a real type ceiling, and K25 extended coverage sprinklers, as Interact sprinklers, we may be able to get away with smaller fire pumps, no fire pumps, a smaller tank, or no tank at all in some cases. All this started with the Fire Protection Research Foundation. Whenever there's something outside the scope of NFPA 13, the foundation gets together a group and we try and solve that problem. In this particular situation, we were trying to provide protection for rack storage of exposed, expanded Group A plastics. The committee agreed to looking at K25 ESFRs at the ceiling and using vertical barriers spaced 4.8 meters apart in the racks. We did a few fire tests. Were the results that great? Not really. So at our company, we've been doing some testing with looking at large K-factor extended coverage sprinklers in the racks to see what they would do. We'd only done distribution testing, so we thought, well, this would be a good time to actually try it in a fire situation. What we were trying to protect with exposed expanded plastics was furniture. But you can't burn up furniture. It's not a consistent fire test. It's not reliable. However, where I come from, the part of the country I live in, burning couches is kind of a weekend treat. What you do is you kind of get drunk on a Saturday afternoon, go into your mobile home, pull the couch outside, set it out in the front yard, light it on fire, and then see how much beer it takes to put it out. Joke doesn't play well in Brazil. Come on. For the actual fire test, we need something that can be repeatable. So at UL, we use the standard fuel package for exposed expanded plastics, which is polystyrene meat trays. The kind of trays that you get in the supermarket that your hamburger comes on, or steak, or other meats. And you can see it looks pretty nasty that they're all stacked up. What we wanted to do again was go along with what the Research Foundation was looking at. They were testing with a ceiling height of 12.2 meters, storage height of 10.7 meters, and the only thing that we did differently was decide to throw in a 10 millimeter plywood horizontal barrier at the 6.1 meter level. So our ceiling sprinklers were K17 ESFRs. We had them operating at standard pressure of 3.4 bar. And for the interacts, we used K25.2 EC 100-degree sprinklers at 2.1 bar. This is the sprinkler. It's FM approved and UL listed as a ceiling sprinkler. But again, we wanted to use it as an interact sprinkler to see how it performed. The reason that we thought it would do well is because it has such a high pattern. With only a 100 millimeter clearance above the commodity, we were throwing water all the way across the commodity, down the face of the commodity. Actually, with a 1.2 meter aisle, we wet the adjacent combustibles. And all that is a 2.1 bar. That's what the piping plan looked like for our test and plan view. That's what it looks like in the elevation view. And this is what it looks like in real life. Again, that's just a 10 millimeter plywood barrier at the 6.1 meter level. That barrier is permitted by both FM and NFPA 13 and it's considered a horizontal barrier. This is what the piping looks like. The piping was run in the longitudinal flue. And we installed the sprinklers only in the longitudinal flue between the uprights. They were 2.5 meters on center. That's what it looks like. You can see the opening at the uprights. Again, that's permitted under FM and NFPA standards. And no sprinklers in the transverse flue, none at the face. Okay, hopefully my guy can, got back up. Hopefully we can start this video a little better. We did Wes's back there. I see the man moving. We're good. This would be like an arson fire. It's actually lit at the aisle. One of the igniters split around one of the uprights. This is going to grow a little faster than the fires that Wes were showing. You'll actually see it when it gets up to the horizontal barrier. You'll see the flame spread sideways. Right there. When we started this burn, we were very fearful of what would happen, but we were very excited when we saw how well it took care of this fire. All right, we get out of that fire test because time is running out already. Okay, we opened 2 sprinklers in the rack. One at 49 seconds and one at 52, and we opened 1 ceiling sprinkler at 1 minute and 2 seconds. Actually, my metrification was pretty bad, so the ceiling sprinkler operated at 3.4 bar and had 450 liters per minute. Each one of the interact sprinklers was flowing 520 liters per minute at that 2.1 bar. Before, after, really minimal damage. This is what we've been doing with the foundation with the vertical barriers. We got a little more damage. We actually got the fire burning around the vertical barrier. The result was we came up with a proposed design of the ceiling sprinklers the typical 12-head design for K-17 ESFRs, which would give you around 5,400 liters per minute. The NRACs we opened 2, but with 50% penalty for design, we calc 3, and that demand would be 1,560. But because you install a horizontal barrier, not leaving it open, you do not have to combine the NRAC sprinklers with the ceiling sprinklers. You don't have to find flow or balancer. So we really don't have a fictitious ceiling at this point. We really have almost a ceiling. If you compared that system with what Factory Mutual currently has in the data sheets, we would need 6,350 liters per minute for 1 hour. What they have in the data sheets right now with the K25 ESFR is 18,500 liters per minute for 2 hours. So substantial water saving. This is going to be what's going to be proposed that came out of the Research Foundation for their fire tests. Again, we'd be 6,350 liters per minute. They're going to be about 9,830 liters per minute. For the second phase of testing, we wanted to get more to the products that are actually out there in the real world, so we wanted to look at carton and group A plastics, probably 90% of all storage in the world. So again, we wanted to look at buildings higher than 14.6 meters, use less water, reduce the number of NRAC sprinklers with the current concepts, and be able to retrofit existing facilities. That's normally what you see out there in storage for carton unexpanded plastics. It could be a metal, plastics material in a box, some small amount of foam in there to hold it in place. And you've probably seen enough of the pictures of this today, but this is how we test carton unexpanded plastic cups and cardboard boxes. We ran a test with that. That was our first test. We put the barrier this time at 9.7 meters. We opened 1 ceiling sprinkler and 2 of the rack units. And the ceiling sprinklers actually were also extended coverage sprinklers. We didn't use the SFRs. Very little damage with that test. So based upon that, we could look at a design at the ceiling using extended coverage sprinklers at the ceiling, calculating only 6 of them. The water demand now would be 3,120 liters per minute, plus or minus. Again, the NRACs would not be added to that. And that's going to be tough to see, but basically, the water demand is lower for high buildings, whether they're 12.2 meters or 14.6 meters. And actually, when you exceed 14.6 meters, there's no way to do it without NRAC protection anyway. And we can do that with around 4,100 liters per minute. We actually have done more than 7 additional tests. We've done about 9 now. We've done flammable liquids, exposed expanded plastics, multiple racks, and many other tests. But the big thing is, where the system is really valuable is in the high-bay buildings with automatic storage and retrieval systems. The fire challenges here are tremendous because you want to stop the fire between barriers and you don't want it to spread from end to end on the rack. How's the fire department going to get in there and fight the fire? How are they even going to find the fire in some cases? So you really have to get extinguishment and maintain that fire in one location. So we ran additional tests with multiple barriers. This one happened to have barriers at 6.1, more than 1 barrier. And not all tests work out the way you want them to. We learned a lot with this test because we didn't do very well. Started the fire within about 3 or 4 minutes. The fire looked like it was extinguished and under the first barrier. We were over drinking coffee, high-fiving each other about what a great test it was. About 9 minutes later, someone said, "Oh, there appears to be a fire up on the second level." That fire then started in the second level, and we had elected not to put water on the ceiling sprinklers because we didn't want the fire to spread out from the barriers anyway. Well, they got the ceiling sprinklers. And anybody ever UL, they had a little difficult time figuring out how to turn the water on the ceiling sprinklers at that point. So anyway, it was not what we wanted to see. But we learned a lot from that. If you have a single barrier, it's okay to leave the space at the uprights. If you're going to have more than one level of barriers, you really need to enclose that space at the uprights, because you do want to create that ceiling effect where the fire doesn't spread from one level to the other. So we ran tests 4 and 5 with barriers at 6.1 and then 9.3, and everything was fine. We, again, opened minimal amounts of sprinklers in the racks, never left the barrier that the fire was started in, and we never opened any ceiling sprinklers. And this is kind of a unique shot here with, we pay thousands upon thousands of dollars to run this fire test. And we want to see fires flaming around the ceiling and getting our money's worth. But with these tests, they're really just boring. Can we fire this one up back there? No, it's already going. This is at the 30-foot level, excuse me, what is that, meters? 9.3? Some level. It's 23 seconds after the fire's been lighted down at the floor. And you can see the flames come up, and you'll actually see the sprinkler over on the right operate once the flames get up at that horizontal barrier. Should see some little embers flickering up here. There it is. Again, for about $115,000, this is really working. And that's it. 10 minutes later, again, all you're seeing is water run down the boxes. So we thought that was pretty good. We decided to go back and look at exposed expanded plastics, but this time to look at multiple row racks. And we actually did this with a 1.2 meter aisle. If I showed you the video for this, we'd be here about an hour and a half, but it really was looking bad. But we did great. Within the first minute, we opened 3 sprinklers, and we thought we had it with those 3. And over a period up to 8 minutes, we opened 2 more. But again, we thought that was very good to use 8 sprinklers to control exposed expanding plastics in a multiple row rack. Yeah, there was damage, but it didn't spread end to end. It didn't jump the aisle. Again, a very successful test. So what do we get out of all this? Basically what we proved was that by installing a horizontal barrier at the 6.1 meter level and using the EC sprinkler, we can do buildings up to 12.2 meters with exposed expanded plastics and have a much lower water demand than we would with ceiling-only sprinklers. For the storage of carton unexpanded plastics in open frame racks, we can put barriers in at 9.1 meters, do buildings up to 14.6 meters, or maybe even higher than that, and we'll have a much lower water demand for those in-rack sprinklers than you would for having ceiling-only protection. And what this is really good for is being able to go into existing buildings where the storage has changed, where the water supply has diminished, and be able to put this system in and have a much lower water demand. And ultimately, for carton unexpanded plastics and double row racks, particularly for the automatic storage and retrieval systems, you can put in multiple barriers, as long as you use continuous multiple barriers, whether they're at 6.1 meters or 9.1 meters on center. We can do really unlimited height buildings that way by creating those fictitious ceilings that Wes had talked about. For that, obrigado. Thank you.